Let's draw two parallel lines. I'm going to call one M and the other L. Now, let's draw another line that crosses these two. I'm going to call this line S. This line S will be a second or transversal. As you can see, a total of 8 angles are being formed, and these 8 angles have certain relationships with each other. That's exactly what I'm going to talk about today. Today I'm going to talk about the relationships between angles that are formed when we have two parallel lines cut by a transversal. So if you want to learn this in detail, please keep watching, because without further ado, let's get started. Look, it's absolutely necessary to specify that line M is indeed parallel to line L. We're going to represent it this way. If these two lines weren't parallel, then the relationships we're about to see wouldn't hold. And what do I mean by relationships? Well, let me quickly tell you one here. For example, just by looking at this diagram, you're probably already noticing that the measure of angle 1 is going to be the same as the measure of angle 5. Or for example, the measure of angle 3 has to be the same as the measure of angle 7. And in this way, we can find more relationships. So right now, what we're going to do is name each of those relationships or see how we can classify them. So come on, let's get started. Vertical angles. Look, vertical angles have the same measure. For example, look at angle 1. Here we have it, right? Now look at angle 3, which is this one over here. As you can see, angle 1 and angle 3 are vertical angles. This means that angle 1 has the same measure as angle 3. And this will also happen, for example, with angle 4 and angle 2, right? These two are also vertical angles. Therefore, angle 4 will have the same measure as angle 2. And right now, we also found some relationships over here, right? But first, let me write this down. Angle 1 has the same measure as angle 3. We're going to write it as follows. We're going to write angle 1, and here we'll put this symbol, which is the congruence symbol. And here we'll now write angle 3. How do I read this? Well, I'm going to read it as angle 1 is congruent to angle 3. What does it mean for it to be congruent? Well, it means that it measures the same location or the same position. What do I mean by that? Well, see that this angle is like this, while this other angle, which is number 3, is facing down. So, even though they measure the same, they're not in the same position. Therefore, we'll say they are congruent, meaning they have the same measure but are in different positions. So, that's why I was saying, here we're going to express it as angle 1 is congruent with angle 3. Are you following me? Let's see. What else? We also agreed that angle 4 has the same measure as angle 2, right? So, let's write angle 4 is congruent to which angle? With angle 2, done. Now look down here and see which ones match with which. For example, angle 8, which one is it congruent with? Very good, with angle 6, right? And the reason is because they are vertical angles. And well, finally, here we have another relationship, right? Which is that angle 5 is congruent with angle 7. That is, they have the same measure, even though they are not in the same position, right? That's it. Well, this simple one would be our first relationship. Don't forget, they're called vertical angles. And here we have the ones we've found. Now let's move on to some that are a little bit more complex. Corresponding angles. Look, as the name suggests, and to put it simply, let's think of them as those angles that correspond to the others. What do I mean by that? Look, let's cover this part here. For example, and notice this arrangement. Now let's cover this part over here and also look at this arrangement. Now think about it. For example, which one could you relate this number to among the ones over here? Or, well, sorry, to this angle, but in relation to the ones over here. Very well. So you could relate it to number 5, right? Because you can see that they're positioned exactly the same, right? Let's see. For example, now, which of the ones down here could we relate angle 2 to? Very good. It would be with angle 6, right? This means then that angle 2 corresponds to angle 6. And who else? Let's see. For example, which angle corresponds to angle 4? Very good, with angle 8. And well, finally, angle 7 and angle 3 correspond to each other, right? So since they correspond to each other, it means their measure is the same. This means that they are congruent, right? Remember that we say they are congruent simply because their measure is the same, even if they are not in exactly the same position. Why do I say they are not? Well, because this one is up here and this one is down here. Even though their relative position with respect to these two lines is basically the same, still, on the plane, they are not located in exactly the same place, right? That's why we say they are simply congruent. So come on, let's write that down then. We write that angle 1 is congruent with, who did we say? Angle 5. Then we said, we remember that angle 2 is congruent with angle 6, right? Let's see, I missed it here. There it is, with angle 6. Then angle 3 is congruent with angle 7. And finally, angle 4 is congruent with angle 8. There we go. Now we also have these other relationships. Alternate interior angles. Let's see. Here it's important to look at these two words. Alternate means, or, well, it comes from alternating, right? For example, if I have a line like this, then I could say that if I have a number here and another one here, well, the numbers are on alternating sides. I mean, one is on one side of the line and the other is on the other side of the line. That's how we're going to think about it, okay? Alternate means being on opposite sides. Now, interior means they're on the inside, right? So which ones are the alternate interior angles? Well, they're angles that are on opposite sides, but on the inside. So, let's take a look at the figure. Which are those angles? Which angles are alternated and are on the inside? Well, as you can see, here we could think that the angles that are on the inside are angle 4, 3, 5, and 6. Right? Look, these would be the interior ones, and the external ones could be 1, 2, 8, and 7, right? So let's consider these as the interior angles. Now let's see which ones are the alternate ones. With respect to what? In this case, with respect to the transversal or secant. So, let's see. Let's check it. Here we have angle 4, for example, which is on the inside. And I want you to see that it's on the left side of the line. Now let's look at who is on the right side of the line, but is alternate. In this case, as you can see, it would be angle 6. Look, angle 4 is inside these two and is alternate with angle 6. Therefore, angle 4 and angle 6 are alternate because they're on opposite sides, and they're also interior because they're on the inside. So, angle 4 and angle 6 will be congruent. That is, they have the same measure, simply because they are alternate interior angles. And there's another pair, right? Which would be the other one? Well, it would be 5 and 3, right? This angle and this angle also have the same measure, for the same reason, because they are alternate interior angles. So let's write that over here. Angle 4 is congruent with which angle? Well, we said, right? With angle 6, correct. And now, angle 3 is congruent with angle 5. All right? We also have that pair now. And look, since I have a little bit of space here, and I hope you more or less understood which are the alternate interior angles, now I'm going to show the alternate exterior angles. With that same idea, what are the alternate exterior angles like? Well, they are those angles, right? That are on opposite sides and on the outside, right? Because it says exterior. So, let's look at the outside angles. Which ones did we say? They were 1, 2, 8, and 7. Now let's look for the ones that are on opposite sides. In this case then, as you can see, 1 is an alternate exterior angle with which one? With 7, right? Because they are alternating and they are on the outside. What else? Well, it would be 8 with 2, right? 8 and 2 have the same measure, since they are alternate exterior angles. Therefore, they have to be congruent. So let's write that down. We say that angle 1 is congruent with angle 7, right? And what else? Well, that angle 2 is congruent with angle 8. That's it. And now, to wrap up this video, let me briefly talk to you about supplementary angles. Supplementary angles are pairs of angles whose measures add up to 180 degrees. For example, I want you to look at angle 5 and angle 6. It's true that I don't know the measure of angle 5, right? Well, unless I use a protractor and measure it, or it's given to me as data. But as it is, I really don't know how much it measures. I also don't know the measure of angle 6. But what I do know is that the sum of the measure of angle 5 plus the measure of angle 6 has to be 180 degrees. Well, in this case, I would say that angle 5 and angle 6 are supplementary angles. Or I can say that angle 5 is the supplement of angle 6, or the other way around. Why? Because they add up to 180 degrees. That is, they give me a straight angle. Therefore, we can express this in the following way. Let's say that the measure of angle alpha, for example, plus the measure of angle beta has to equal 180 degrees. Wherever that is true, it means that they are supplementary angles. Don't forget that. I'm just going to write a few because there are actually quite a lot, right? For example, angle 1 with angle 2. So let's express it in the following way. I write the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. Or, well, it gives 180 degrees in this case, right? Since here we can clearly see that these two form a straight angle. What else? Let's see. Let's take another pair. For example, this one and this one. I mean 6 and 7. So I would have that the measure of angle 6 plus the measure of angle 7 also equals 180 degrees. And well, I could add more. I'm going to add another one, just one last one, because that's where it often gets complicated for us. Look, it's also true that if I take, for example, this angle and add, for example, this angle over here. Look, this 8 plus this one over here will also give me 180 degrees. Right? Why is that? Well, for the following reason, look. I already know that this angle measures the same as this angle, right? Why is that? Well, because they are corresponding. Since they are corresponding, they measure the same. Now, since this one and this one measure the same, and also, we already know that this angle 4 and this angle 3 together make 180 degrees. Well, then it also has to be that the measure of angle 8 plus the measure of angle 3 has to add up to 180 degrees. So that means angle 8 and angle 3 are also supplementary angles. So I'm going to write that down as well. And here you can find more relationships, okay? So I write that the measure of angle 8 plus the measure of angle 3 has to add up to 180 degrees in total. Done. And well, I could add more, but I'll stop there. Look, just so I can see that you really understood, I'm going to give you a homework exercise. I'll do one, and I'll leave one for you as homework. If line L is parallel to line M, look, here they are, and the measure of angle A is 65 degrees here is angle A. What is the measure of angle B? Here we have angle B. I'm going to answer this one. Let's see. Look. Again, here we have the two parallel lines, and here we have the transversal, right? So, in this case, since I want to know the measure of angle B given the measure of angle A, let's look at the relationship between them. As you can see, here we have alternate interior angles. And as we mentioned before, since they are alternate interior angles, their measures are the same. Therefore, the measure of angle B will be the same as the measure of angle A. That is, angle B also measures 65 degrees. So let's write that as the answer. Where? Here, right? So the measure of angle B is 60 degrees done. We're finished. Sorry. 65, 65. There it is. Then it says, why? Oh, that's easy. Because angle A and angle B are alternate interior angles. Done. I already wrote it over here. Because angle A forms an alternate interior pair with angle B. Done. Well, now it's your turn with this question. How big is angle D? We have it over here. And it also asks why. Well, in this case, I would like you to solve the exercise in your notebook. And when you have the answer, put it down here in the comments. I'm going to give a nice heart to everyone who gets it right. And well, that's all for today. I'll move over here a bit so you can copy the exercise. If you liked this video, please subscribe to the channel. I'm uploading videos every day. See you next time. Take care and behave yourselves. Bye-bye. Go ahead and copy it.